Good morning everyone. Today we are going to discuss regarding software engineering and the course code is 21HC45T. So the total credit for this software engineering is 3. We will discuss regarding a course outcome. So CO1 explain the concept of software lifecycle model. CO2 analyze the software requirement specification and design software according to the specification. So in unit 1 we have a software process and agile development. So we will see what are the list of content in unit 1. So one is introduction to software engineering, then software process and process models, prescriptive process model, specialized process model, agile development, extreme programming, XP, XP process and other agile process model. Okay. So first of all we will see what is software engineering and we will have a definition regarding this one. So a software engineering is a discipline in which theories, methods and tools are applied to develop professional software product. So we have a discipline, theories, methods, tools where we can develop the software product. So in this there is a discipline with two different disciplines. One is product and discipline. So these are the software engineering based on two terms. So what is discipline? Actually it's a engineer where we are going to apply some theories, methods and tools based on the engineers and the organizational constraints, right? Product. So product is nothing but where we are going to get the software and develop based on systematic theories. So systematic theories, methods and tools for a product, but in case of discipline we are going to see based on a particular engineering concept where it is applied on theories, methods and tools, right? So next, so what is this software engineering have a different set of rating of the software. Actually one is idealized curve and actual curve. So there are some failure curves in the software engineering based on hardware and software. So failure curves in case of bathtub curves. So why it is called as bathtub curve means the failure rate and the success rate will be based on a U type, okay, boat shaped. So that is called as bathtub curves. Now we have two different curve. One is hardware curve and a software curve, where the failure curves of hardware and software is depend on the failure and time consuming. So here in hardware curve you can see there is a wear out. So wear out in the sense where the hardware is manufactured based on some defects, we have a different wear outs where constant failure period is there. So if there is a constant failure period, then the hardware will be wear out. In case of software curve we have a failure and a timing also, but we have a change in the middle. So this change will have a side effect of changes where actual curve is again it is extended to the future end. So the idealist curve will be there, but the actual curve we can extend the changes. Based on some changes we are going to extend the lifeline of the software, right? So next one we'll have a discussion regarding layered technology. So before moving to layered technology, there are some categories of software based on Java, Perl, CGI, HTML and DHTML. Okay. So this layered technology will have tools, methods, process, quality management. So where we have some process layer, method layers, so different layers are there. We will see that one by one. So, what is called process layer? Process layer actually is a foundation of software engineering. Method layer is the implementation where it is carried out by with the help of designing, coding and programming. Okay. So, next software tools where it is going to bring some automation in software development. So, this entire software engineering is a combination of this process, methods and tools. So, help to develop a quality software, right. Next one, that's a software process. So, we have a definition. Software process can be defined as the structured set of activities, that are required to develop the software system. So, if it is a set of activities that is in structure form, means we have some fundamental activities in this process. Process in the sense software process: 1, specification, validation, designing and implementation and evaluation. So, this is the software model is an abstract representation of a process. So, if it is an abstract representation of a process, means it presents a description of a process from a different particular perspectives. Okay. So, we have some common process framework for this one, where different types of activities are carried out in a different framework structure. One is umbrella activities, process framework and software process. So, this is how the activities are carried out. One, the framework for activity 1 having a task set, where it is going to work on some milestones and SQA points. So, it is a task set having a activity 1 as a framework, again activity 1 to n framework, okay, within the umbrella activities. Then comes the process framework and the software process, right. So, next so, we will see what is the before moving to next one, CMM is another one important capability maturity model. So, where we can develop comprehensive process meta model and emphasizing process maturity. So, it has level 1 as initial, level 2 repeatable, level 3 defined, level 4 managed and level 5 optimizing. This is how the CMM level 1 to 5 is segregated, right. Next one is waterfall model. So, waterfall model actually it is also called as a linear sequential model or classical life cycle model. So, this is a oldest software paradigm. So, where we are going to suggest some systematic sequential approach to software development. So, this development is actually is a requirement gathering pace. So, it has analysis, design, coding, testing and maintenance. So, waterfall model actually flow from the right. So, example, in a staircase, if you are pouring water in the top of the staircase, means then water will flow from the right side only and there will not be any change in the middle, right. Next, incremental model. So, incremental model actually is created for the user. So, to understand about the software product, and this model is refined and explained, okay, in 4 different types: 1, analysis, design, code and test. So, this incremental model in software functionality based on different time limit, we are going to have a increment 1 to n. So, where a set of increment where it is going to operate based on analysis, design, code and test. So, this increment with enhanced functionalities from incremental 1 to till the nth element. Next, RAD model. So, what is called RAD model? RAD model is a type of incremental process. So, this is a type of incremental process. So, there is a extremely short development cycle. So, actually we can understand this based on some component based construction also, which is adopted in a RAD model. So, usually this RAD model is going to have functional system based on 60 to 90 days, that is very very important. So, RAD model have a functional within the 60 to 90 days, right. Next, so 60 to 90 days in the sense we have a different teams. So, team 1, 2 through nth team, where the team is going to design the product and build the product. So, based on this, the 1 to nth team will finally send a final result to the deployment. But in this case, where development process is based on different teams from 1 to n, but all the requirements and planning and analysis taken, then only it comes to the development process. So, the development process entirely will have a 60 to 90 days period only. Within that, the RAD model will be completed, the process will be deployed. So, RAD is nothing but rapid application development. Next, so prototype model, this is a key model. Why it is a key model means, so whenever this product initially is required, that is we are going to gather and it is done in the middle itself. So, there is a build quick design. So, building of a different process in the middle itself. So, if the customer is going to make any changes or required based on some changes or needs and wants is more means, then in the middle of the process itself the quick design can be applied, and again based on that we can construct and develop based on the feedback, and we have a communication with the customer and finalize the design. So, this prototyping model is a quick design where design represents what will be visible to user in input and output format. So, for a this prepared based on customer or user is going to evaluate the prototype in order to refine the requirement. So, it is iterative prototype where it is going to tune and satisfy the customer requirements. So, next comes the iterative nature. So, iterative nature based on a spiral model. So, what is called spiral model? So, spiral model is going to be segregated in 6 different parts. So, 1 customer communication, planning, risk analysis, engineering, construction and release, customer evaluation and feedback, and project entry point exist. So, this is a this model is a iterative nature of a prototype model, as well as it is controlled and systematic approaches of the linear sequential model. So, it is divided into number of framework activities. So, these framework activities actually is denoted by task and region. So, usually there is a 6 task region, as you can see in the diagram, and as well as this approach is a realistic one, and it is a large scale system, and this problem statement will be at each evolutionary level. So, also there will be a risk, we can identify and rectify that in initial passes. So, passes is nothing but the product specification that is built in subsequent passes. The product is built in subsequent passes around the spiral. Okay. So, this is the version of a software where we are going to get developed again and again. So, during the planning phase, what happen? We will get the feedback from the customer, and in the project entry point axis, starting point for different types of project. Again new project will be evolved. So, this is a entry point 2 where the product development process is going to starts. So, this is how the process is being done in a software model. So, next there are different task region, as I said, customer communication, where it is going to establish communication between different regions, and planning, all planning activities are carried out, and risk analysis, where we are going to take required to calculate technical and management risk which are going to be carried out, and engineering concept, the task region or task required to build one or more representations. So, next one is concurrent development model. So, the concurrent development model definition for this concurrent development model is also called as concurrent engineering. So, in this model, the framework activities or software development tasks are represented as states. So, states in the sense the modeling or designing phase of software development can be in one of the states like under development, waiting for modification, under revision, or under review. Okay. So, based on this, the transmission from one stage to another is passed to modeling activities. So, modeling activities will have under development, waiting for modification. After that, you will get or receive revised or reviewed based on a baseline and a completion process. So, it is represent different states, which means initial communication is done through the modeling activities. So, this model actually have various activities that can occur concurrently, and a network of activities is defined. So, this is called as during the modeling, actually under development, waiting for modification states occur, where it is defined a series of event. This series of event is going to have a transition from one state to another state. Okay. This is very important, transition from one state to another state, that is called as triggering. So, this is a network of activities. So, next one. Next one is specialized model. So, what is the specialized model? So, in a specialized model, we have a different activities for a formal method models. One is user requirement, system, architecture, formal specification, and high level design. So, in this model, there is a software engineering which is going to specify or develop and test the computer based system using mathematical notation. This is very important, using mathematical notation. So, what is called notation? So, notation is going to specify within the formal methods. So, within the formal methods, since it is notations are specified within the formal methods, we need there is a clean room software engineering. So, what is this clean room software engineering? Which is going to use formal method approaches. The main advantage of this one is ambiguity, incompleteness, and inconsistency. So, it will overcome the use for a formal method models. Then next one is agile manifesto. So, what is this agile manifesto? Actually, this is called as manifesto for agile software development. We can declare with 4 key values and 12 principles. So, there are some weakness we can overcome, but agile manifesto can be represented as individuals and interaction over process and tools, working software over comprehensive documentation, customer collaboration over contact negotiation, responding to change over following a plan. So, this is a agile manifesto where there are some 12 principles to guide, and we have an interactive with a people to centric approach to software development. So, the agile methods were developed to overcome the weakness of conventional software engineering. So, in this agile manifesto there is another agile process. So, what is this process? Actually this process have started in 1980s based on some heavyweight plan based software development, and this approach is going to be directly related to software product that is being used. So, this approach was actually a rigid one. So, where the network was essential to different requirements that can be made. So, this agile process have a lightweight methods that are people based rather than plan based, people based rather than plan based method. So, this agile process is having a